Now that we've calculated the amount of work done in a simple situation, let's do a slightly more complicated one. So for this situation, imagine you have a frictionless surface, and on the frictionless surface is a box. Doesn't matter how much the box weighs. And the box is being pulled via a pulley. And the pulley's pulling it down, and there's a 10 kilogram weight connected to it. So here's some assumptions you can make to make it a little easier. First of all, assume that the angle the rope makes to the horizontal is always 30 degrees. And we're assuming drag a short enough distance, this doesn't change. Assume the box is dragged forward 100 centimeters and then stops. And then assume it's frictionless. Based on this information, then try to calculate how much work is done on the box as it's dragged. Now pause the video. If you get stuck, unpause it. I'll give you a hint, and then you can try it again. Okay, so here's the hint. You need to figure out what the force done in the x direction is. And if you remember from previous videos, when you draw an angle between the horizontal and the angle, you can use the cosine to figure out the force. So we're going to say that force sub x equals force times cosine of 30. So pause the video again if you haven't solved it already and try to solve it, and then we'll go over the entire thing. Okay, so going over what we have, the first thing we need to do is calculate the force. And as we calculated in the hint, force is cosine of 30. And that's because we only want the horizontal portion. So what's the total force along the wire? Well, this is the tension, and the tension is being caused by gravity. So what force does gravity exert on the block? 10 kilograms times 10 meters per second squared. And for the purpose of this, you can always use 10 meters per second squared as gravity. It's not exactly accurate, but it's close enough. But anyway, that's 100 newtons. So what can we do with this 100 newtons? Well, we need to find the force in the x direction. So force in the x direction is 100 cosine of 30. Now what's cosine of 30? Cosine of 30 actually comes out to be radical 3 over 2. And that's because it's a 30, 60, 90 triangle. If you haven't seen this, don't worry. But if you have, what you can remember is this side is 1, this side is 1/2, and this side is square root of 3 over 2. And then when you go and you do the Pythagorean theorem, it comes out, it becomes 3/4 plus 1/4 is 1 squared, so it works. So the cosine is the ratio of the horizontal to the hypotenuse. So it's the ratio of radical 3 over 2 over 1, which just comes out to be radical 3 over 2. So going back to our equation, that means the force of x is 100 radical 3 divided by 2. 100 divided by 2 is 50, so 50 radical 3. So now we know our force. What do we know about work? Well, work is force times distance. So what force is being exerted? Well, we know that. 50 radical 3. What's the distance? 100 centimeters. But wait a second. 1 joule is 1 Newton meter. This is in centimeters. So we've got to do some unit conversions. Times 1 meter is 100 centimeters. So that cancels out. So now we're in the right units. This is 50 radical 3 newtons times 1 meter. That'll be Newton meters. So we do 50 radical 3 joules of work on the box. And if you can do this, you can do almost any kind of work calculation, because all the work calculation stems from these very simple assumptions we've made. And the only one that's really tricky is going back, is figuring out what the angle is. And what you always have to do is you draw a line that represents the direction of motion, draw a line that represents the direction of force, and then do cosine of the angle in between. And that'll get you the ratio you need, which will let you calculate your force. And once you have your force, you can calculate your work, and then you'll get your answer. If you got this, you're now ready to move on to the next problem.